Welcome to Phase 5, Optimization. Every database eventually gets the dreaded complaint. It's slow. This chapter is how you respond like a professional instead of guessing. Here's the reassuring part. You do not need to be a world-class tuning guru to interview well. What you need is to know the names of Oracle's diagnostic tools, AWR, ADDM, the advisors, and to have a clear method for chasing down a slow database. And the single most important principle, the one that runs through everything, is this: measure before you change. Let me show you the tools and the method, and by the end you'll be able to answer, the database is slow. What do you do with real confidence? Let's start with mindset, because it's a philosophy before it's any command. The first rule of tuning is, you find the actual bottleneck before you change anything. It's so tempting to hear it's slow and immediately start adding indexes or bumping up memory, but guessing wastes effort, and worse, it sometimes makes the problem worse or masks the real cause. The professional approach is to measure first and let the evidence tell you where the time is going. And here's the good news for interviews. Oracle gives you a built-in measurement system for exactly this, and knowing those tools by name is most of what you'll be asked. So the whole chapter is really, what are the measurement tools and what's the method for using them? Measure before you change, say it, mean it, lead with it. The first tool is AWR, the Automatic Workload Repository. Think of it as the database's flight recorder. Periodically, by default about every hour, Oracle takes a snapshot of performance statistics and keeps it for a retention period. Then, to investigate, you pick 2 snapshots and generate an AWR report covering that window, and it shows you exactly what the database was doing. The top SQL statements by time consumed, the top wait events, and the load on memory and I/O. So if someone says it was slow between 2 and 3 p.m., you grab the snapshots bracketing that window, and the report tells you what happened. And a nice detail that connects chapters, those snapshots live in the sysaux tablespace from Chapter 8. That's part of what sysux is for. AWR is your history. It records so you can investigate after the fact. AWR gives you data, but raw statistics can be overwhelming. That's where the second tool comes in. ADDM, the Automatic Database Diagnostic Monitor. ADDM runs on top of the AWR data and does the analysis for you. Instead of making you squint at pages of numbers, it looks at the snapshots, identifies the biggest problems, and hands you concrete recommendations. Things like this SQL statement is consuming most of the time, or consider increasing this particular memory pool. The analogy that makes it stick: AWR is the raw data, and ADDM is the doctor who reads that data and gives you a diagnosis. So in practice, you often go straight to ADDM's findings first, then dig into AWR details if you need to, naming both and explaining that ADDM interprets what AWR records, shows you understand how they work together. Now the central concept of modern tuning, the wait event. At any given instant, a session is doing one of 2 things. It's either working on the CPU, or it's waiting for something. Waiting for a disk read to come back, waiting to acquire a lock, waiting on a latch, waiting for a network round trip. By looking at which waits dominate, you learn where the time is actually being spent. 2 quick examples. Heavy weights on disk reads point to an I/O problem or a missing index causing full table scans. Heavy weights on locks point to contention, sessions fighting over the same rows. This framing, what is the database waiting on, is the modern, correct way to talk about performance. It shifts you from guessing to diagnosing. So whenever you discuss tuning, anchor it in wait events, and you'll sound current and precise. Oracle also bundles several advisors that go a step beyond diagnosis and recommend specific improvements, and you should be able to name a few. The SQL Tuning Advisor analyzes a single slow SQL statement and suggests fixes, a better execution plan, a new index, or a SQL profile. The SQL Access Advisor is broader. It looks at a whole workload and recommends indexing and materialized views. The Memory Advisors recommend sizes for the SGA and PGA pools, tying back to Chapter 3. And the undo advisor recommends an undo table space size for a target retention, tying back to Chapter 9 and our ORA 01555 discussion. The unifying theme is lovely. Oracle will tell you what to do if you ask it. So, part of tuning is simply knowing which advisor to consult. Naming 2 or 3 of these signals, you know the toolbox is well stocked. Here's a quiet but high-value topic: optimizer statistics. The Oracle optimizer is the brain that decides how to execute each query, which index to use, which join order, whether to scan or seek. But it can only make good decisions when it has accurate, up-to-date statistics about your data. How many rows a table has, how values are distributed, and so on. Oracle gathers these statistics automatically on a schedule, so most of the time you don't think about them. But between gatherings, statistics can go stale, especially after a big data load or a bulk change, and stale statistics are one of the most common real-world causes of a sudden slowdown. The optimizer, working from outdated numbers, picks a bad plan. This sets up a fantastic practical instinct to have, which is the very next slide. Here's the instinct that makes you sound experienced. Picture the scenario. A query that ran in a second yesterday now takes a minute, and nothing obvious changed. No new code, no new load. What's one of the very first things you check? The statistics. There's a good chance a big data change left the stats stale. The optimizer is now working from outdated numbers, and it picked a bad execution plan as a result. You gather fresh statistics, the optimizer sees the real shape of the data again, and it often goes right back to the good plan. Mentioning this in an interview, if a formerly fast query suddenly got slow, I'd check whether statistics went stale. Instantly signals hands-on experience, because it's exactly the kind of thing you only learn by living through it. It's a small line with a big payoff. Now the payoff, the method to recite when they ask, the database is slow, what do you do? 5 steps, in order. 1. Confirm and scope the problem. What's slow? For whom and when? Vague reports lead to wasted effort. 2. Look at current activity and the dominant wait events to see where time is going right now. 3. Pull an AWR or ADDM report for the affected window to find the top SQL and the real bottlenecks. 4. Check whether the optimizer statistics are current. Remember, stale stats are a common cause. And 5. Only then apply a targeted fix, an index, a parameter, more memory, and measure again to confirm it actually helped. Notice there's no guessing anywhere in there. Method beats memorized commands every time. Walk an interviewer through these 5 steps, and you've answered like a seasoned professional. Let's put the method to work with real views. To see what's happening right now, $session shows the active sessions, and this is the key part, the event each one is waiting on, and its wait class. That's your live wait event view. $SQL, ordered by elapsed time, surfaces the most expensive statements, your top SQL. $system event gives you the system-wide picture of what the database waits on most overall. And $active session history lets you look back at recent activity in fine detail, while the DBA hist views hold the longer AWR history. So the workflow maps right onto the method, active sessions, and their waits, then the top SQL, then the history. Learn this handful of views, and you can actually run the diagnosis you just described, not just talk about it. These all come together in Chapter 17. Let's lock it in. The golden rule. Measure before you change, diagnose from evidence, never guess. AWR is the flight recorder that takes snapshots. ADDM is the doctor that reads them and gives you a diagnosis. Frame all tuning as wait events. What is the database waiting on? The advisors recommend specific fixes, and stale statistics are a common, sneaky cause of sudden slowdowns. Above all, be able to recite the method. Confirm and scope, look at waits, pull AWR or ADDM, check statistics, apply a targeted fix, and remeasure. Now, you've noticed that every single chapter has ended by proving things with $, and DBA views. Our final chapter pulls all of those together into one reference you'll use forever, the data dictionary and dynamic views. That's Chapter 17, the finale.